Hi, I'm Will from HashLDash and welcome to this Photon Devlog episode. Today we'll take a look at the Photon's parser and grammar and how it works, and we'll make an example to see it in action. So without further ado, let's get started. Okay, so first let's talk about the grammar. The grammar is what makes Photon look like Photon. It's what makes Python look like Python code or English. So there are the rules that define what's valid Photon code and how it should be written. So let's take a look here at the Photon grammar. So here we have the grammar, and let me first explain how this grammar works. So the first thing we see is a name, then equal sign, then another name or patterns. So the first thing is the callback. It's when we look at this pattern, we call this function in the lexer. The lexer is the part that analyzes the tokens and convert different types of tokens into other tokens. And we are going to simplify this, the line of code to a combination or one token. And then we will get this token, put in the parser and the interpreter, the engine and all of that, the transpiler. There are several parts here, but let's just focus on this grammar and the parser today. Right, so okay, when we see a pattern like hashtag, we see the token hashtag, then there's a hint here that this is a comment. So let's analyze this list of tokens, the line of code, and if it is a token, a comment, then we will convert this to a comment token, right? Let's see another example. Single quote. When we see this pattern, then maybe it's a string or a double quote. So these are the rules that defines what is a string defined in Photon. So it starts with a single quote or starts with a double quote. And then the lexer will take a look at the tokens and see if it is really a string, right? For example, if we have a comment that has a single quote, then it's not a string, it's just part of the comment, right? So it's not a valid string. And so this is the lexer's work to identify, see if it's valid or not, and all of that. So it's a little bit different from other languages, but this is how Photon is implemented. And here we have another concept, which is the parens in the grammar. And this just means we have a type, then a begin block, then a number, or we have a variable, then a begin block, then a number. So instead of writing multiple lines with all of the combination of the tokens, we can just specify the group of tokens in the first part, then the second part, and so on. So a map type is defined by a type, the begin block, and another type, or a variable, begin type, and so on, and all of the combinations possible here. So we have type declarations, variable, float numbers, groups, expressions, assignments, and the print function, the built-in print function, right? Okay, so these are the rules that makes Photon, the Photon syntax valid and what it means for this sequence of tokens. So this is a guide of, for example, in English, if you want to write a phrase, then you must know the grammar for that, and adjectives and pronouns and all of that, and the rules. And also Python. So Python have already has a bigger grammar. So if you go to docs, Python 3, python.org, and you can see the grammar here. So this is the grammar for Python. They have statements, expressions, and all of that. So it's a little bit different from what Photon's grammar is. But here you can see, let's see a nice thing. So they have the alg assign, the assignment like we have in the Photon. So yield, assert, del, import, if, elif, while, and so on. So let's take a look at the while, for example. A while statement is given by a while name, then named expression, then colon, then a block of code which you will iterate, and this is there's the else block here. This is strange, right? While with else, and this means that it's optional. So let's try that and see if it's valid Python. So looking at the grammar, yes, it's valid. So looking at this, we can say while true, true is an expression, colon, then a block of code like print hey, then we can break or not. So let's break here. And then let's say else. And well, this is going, so say else here. So let's see if this is valid Python. So let's execute that. And here we have hey. So we have a while true, then it run here, the hey, and ignore the else here, but it run. And the else it's because of the break. So if we didn't break, then the else would run. So let's try. So while, let's define a equals 2. So while a less than 3, less than 4, say a plus equals 1, print looping, and then let's say else, print finish. So here we can see the else working the while loop. So we have looping, looping, and then finished. And this you can monitor if you reached a breakpoint or not. So this is what the else is in Python. So this is cool, right? You can just look at the grammar and discover things you didn't know about the language. So this is very cool. And you can use that in all of the languages. All of them have grammar files like this. Peg parsers and all of that. They all use some kind of grammar. And Photon is the same. So if you want to see what you can do with Photon, you can take a look at the grammar. So here we can make assignments. So a equals 2 and so on. We can print. So let's try to run some examples and see the grammar and the parser in action. So let me clear the screen here. We have a main file. So this is what I have opened here. So this is this main.w. It's here on my right. And let's try, for example, a equals 1, right? let's try to run that. So Photon main.w, and here we can see I turned on the debugging output here. So this line is converted to tokens first. So A is a variable name, then we have the equal sign, then we have a number, right? This is what this line is for the parser. And then it will take a look at the grammar and check for some patterns. So here it found that this pattern is in this line of code. So number, what is this number pattern? Let's take a look at the grammar. So number is an expression. So if we see this pattern, a number, then we tell the lexer to analyze and see if this is an expression. And if it is, then the lexer turns this token into an expression token in the next line here. So number was converted to an expression here, right? Okay, here we have another pattern, variable. And it's here, variable. Variable is an expression. So the lexer is trying to analyze and see if this is a valid expression, and here it is. And now we have another pattern, expression equals expression. Let's see what this is. So expression equal expression is an assignment. So this is telling lexer, take a look at this and see if you find an assignment here, and it found and converted this line to an assigned token, right? So this is the process. Find patterns, define it in the grammar, and simplifies to more complex tokens. So this is the assignment token, and this can be used for send to the transpiler or the engine to run this token as an opcode, an instruction to our virtual machine. But that's for the next devlogs. So here's the process, the parsing process of Photon. So let's try to make a print here. Right, so let's run that, and here we have the same process, var equals num, and then find patterns, expression equal expression, then we have assignment, and then it finishes. There's only one token. It's the most simplified token we can get from this line of code. Then we jump to the next one. We process that and start parsing the next line. And the next line is print parens a parens. So this is the sequence of tokens. So print left parens, variable right parens, and it starts asking the grammar and the lexer to simplify this. So it found the pattern variable, converted var to an expression. Then we have another one, which is left parens, expression, right parens. So let's take a look at the grammar here. And here it is, left parens, expression, right parens. And this is a group. So what is a group? It's like asking for Python 1, 2 times 3 plus 2. So this is a group, a parens here. So you can evaluate this expression inside the group first and then multiply by 2. So if we didn't have this here, we would have 8, but if we define the group 3 plus 2, then we have 10. So a totally different result, right? So this is grouping, and we have parens, an expression, and then parens. But let's take a look. the lexer didn't convert this pattern to a group token. And why is that? It found out that this is not a valid group token, and it found out that this is another pattern, print left parens, expression right parens. And actually this is the right one, and it found this pattern instead, and then converted this into a print func token and execute that, and here we have the result, which is 1. So we printed 1 to the console. So you see there's a lot of complexity here. It's not as simple as it sounds, and because of precedence and all of the edge cases that we have in the grammar and all of that. It's not an easy task to do this, but you can see all of the process, and then you can start to manipulate all of these tokens and do whatever you want and execute the code, or analyze if it's valid syntax. So when you're writing Python and your IDE is showing errors, it's looking at the grammar and seeing if it's valid or not, if you defined variables. So if you have assignments, then it's defined. If you didn't have this, then you say A, the IDE will say A is not defined. I didn't find any assignment here in your code. So you can do a lot of things with this, and this is everywhere in your editor and all of the languages and all of that. Okay, I think this pretty much covers the basic of the grammar and the parsing, and I want to hear in the comments what you think about this. And we are going further with this grammar, so you can take a look at the grammar and see what else we have implemented. So this is not the full grammar. Every day we are adding more things here, so you can do more things as we go. So take a look at the grammar and see what's possible with Photon. So I hope you liked this video. If you did, please hit the like and subscribe to receive the next devlogs, and take a look at the GitHub and see if you can write a simple hello world and play with Photon, and tell me what you think about this project, what you could do with the Photon. And that's it. Thanks for watching, and I see you in the next episode. Bye bye.